Everyone, it's Microwave Sam. In this video, I'll teach you how to create website graphs from CSV files. If this is the type of line graph that you're looking for, then this is the video for you. Before we get started, let's take a look at the source code. This GitHub link will be available in the description. If you're already familiar with developing, then I highly recommend you to look at the source code instead of watching the entire video. There are two libraries that we'll be using today. The first library is the chart library called c3.js. c3.js is available at c3.js.org. It can create a variety of different type of charts, including line, bar, stacked bar, pie, etc. The second library that we'll be using today is called PapaParse. PapaParse is available at papaparse.com. PapaParse will be used to parse the values from a CSV file. Now, before we get started, the video objective will be to teach you how to create graphs as independently as possible. When I think of developing something on a website, I always like to use examples. Examples are very good to get started. At the c3.js.org examples page, we can see all the charts that are available to us. Line, time series, bar, stacked bar, part, pie, donut, etc. Let's take a look at line chart. I'm going to delete this extra stuff at the bottom. The bare essentials that you need to create a chart with c3.js is about 8 lines of code. Take a look at this. c3.generate uses c3 to start generating a graph. Now all you do is input the data. The thing that you should do when developing with c3.js is take a look at examples and copy and paste. If you're looking for a bar chart, go to the bar chart example and copy and paste the code. This is how you will learn how to create website graphs from CSV files. Now, if we take a look over here, basic line chart, the columns represent all the places that the y-axis is hit on each of these two lines. If we delete one of these lines, we can see one line disappears. The cool thing about c3.js is that we can also make one line disappear and the whole y-axis scales to that line. It's cool features like this that make me prefer c3.js because there are many graphing libraries, but c3.js just makes everything so easy to develop with. I only need a chart that looks pretty and provides a nice toolbox. Nothing too fancy, nothing too complicated. If you're looking for easy to create graphs, c3.js is for you. Now, how does PapaParse work? Well, to parse a local CSV file, you basically use papa.parse, put in the file name, put this complete section with a function with a parameter called results, and all the data will be available in an array format called results.data. That's how papa.parse works. But to really get a sense on how this all comes together, I have created a folder called graphs-from-csv. Now this project folder contains 3 folders inside of it: data, JavaScript, style sheets. Data contains the CSV file that I will be manipulating. JavaScript contains the dependencies. c3.js is here. It depends on another JavaScript file called d3. This is why I have a file called d3.js. And then PapaParse is over here. Create-graph.js refers to all the graph code that we'll be using. Style sheets. I'm using bootstrap.min.css for making my website look a little bit prettier. c3.css is a complement to the JS file to make the charts look pretty. There's Font Awesome, another CSS file for styling purposes, and then style.css for any of our custom styling. Then we have the main file, index.html, which is all the code you see here. Now, how do the connections work? Basically, you have to connect to c3.css. You have to make sure that you connect to d3.js before you connect to c3.js. Papaparse, and then finally create-graph.js is at the bottom to actually take advantage of these two to create the graphs. Now, let's take a look at the CSV file. What do I have for my CSV file? As you know, CSV stands for comma separated values. We have the categories at the top, and we have all the values at the bottom. This particular file is a dataset containing all the silver minted in Spain from 1720 to 1800. I took this file from a random site online. Now we will be putting all of our functionality in this file, create-graph.js. I've put a couple of functions to get us started. The first function, parse data. We want to parse the data before creating the graph. So there's the parse data function and create graph function. And at the bottom, this is how we start everything. Start. Now, how this works is all I did was I took a look at the PapaParse documentation. At the front page, they have this little thing, parse local CSV file. Copy, and then you paste. We can check out additional documentation. When we parse a remote file, we have to use this download:true. Now let's compare what we have right now to what was on the documentation. This is what I mean about parsing data. So down here is what we saw on their documentation. This is what we have currently. The difference in mine and the documentation file is that I have replaced file with the name of Spanish-silver.csv because this is a CSV file that I'm parsing. I added this download:true because what I want to do is make this file, this whole project, on a web server. When you do this, you need to add this download:true because technically you're referring to a different part of the website and you need to use download:true. If I only want to parse a local CSV file that didn't exist on the web, then this would be satisfactory. But in my case, I'm going to serve it on a website, so I need this download:true. Next, I do the same thing as the complete colon function results, but instead of just console logging the actual data, I do this create graph result.data. What this means over here is that this results.data will be carried into this function. And in this function over here, we will put all of our creating graph code, all of our C3 code. Now, let me delete the documentation that was provided by PapaParse and take a look at what we currently have. We can right-click and open in browser to open the index.html file in a browser. And you can see that it's completely empty. Now, when we get started with PapaParse, c3.js, or any website project, we always want to open developer tools, which is web console. Now, we see a problem already. XHTML requests cannot load our CSV file. JavaScript has this thing for web browsers where cross-origin requests do not work. Basically, this means that you must have a web server hosting the site to be able to parse CSV files with JavaScript files. Now, what that means is that we should open a terminal. Now, let's see here. Right. Let's open a new Cygwin terminal. I'm using Cygwin on a Windows machine. We need to check one thing before we get started. I am going to use Python, which is a programming language, to be able to host my website locally. If we type in the command python --version, we can see the version number of Python that you have. If this command is successful, then you are good. The requirement is set. Now we have to go to where our project folder is, graphs-from-csv. Traverse until you get there. I have a shortcut called repos that brings me to my repos folder. If I ls, I see all my projects, and I want to go to graphs-from-csv. CD stands for change directory, ls stands for list the contents of a directory. So I'm using CD to switch into the graphs-from-csv folder. Now I ls and I see the contents of my graphs-from-csv folder. It matches the contents that I see in my note editor. Now, what I want to do next is I want to use Python and use -m. -m stands for module. And I'll use something called HTTPServer. This will take the contents of the current directory and host it on a web server that will be local. hit enter, and it says serving HTTP on localhost 0.0.0.0 port 8000. Now if we open graphs from CSV again, we will do localhost colon 8000, and this is the location of the web server. We hit enter. Python is serving our website at this location. We can tell by the title, it's graphs from CSVs. And we want to open the developer tools again. We look at console, and then we see this thing, array82. Where did this come from? Well, it came from the console.log that we left over here. Console.log prints things to the web console. If you're not familiar, console.log is your friend. And we're printing the contents of results.data to see if PapaParse has parsed the CSV contents successfully. If we hit this arrow over here, we can see the contents of what this array contains. Okay, it contains 82 arrays with length 4. If we open the first one, we can already see that it has the names of the categories of my CSV file: year, situados paid, silver minted, etc. Let's open our CSV file again. We see there is year, situados paid, silver minted, was American Revolution. We see the contents match. PapaParse is working successfully. Now for part 2, how do we create the graph? When you want to create a graph, take a look at c3.js. Look at examples. Examples are your friend. If we want a line chart, we just go to the line chart. But what we exactly want is we want a simple XY line chart with a custom X, because what we saw with this original example is that the X coordinate was not custom. It took the amount of Y coordinates that we had and then just started from 0 to how many elements we had in that array. So let's take a look at this example first. We see something interesting. We see that in data, we can define x:x, and we can choose custom x values. Okay, this is pretty useful, but I don't like how it's separated very far. What we need to look at is a different example. You keep on looking at examples until you find one that works for you. Now, I know from the top of my head the category axis. What this is useful for is if we have something like categories, since I'm not using numbers, well, I technically am using numbers, I'm using years, but let's say that you have different categories like cat1, cat2, how do we set that up? We look at the example, and you can just use that example for your graph. Oops. Let's copy and paste this to see if C3 is actually working in our project. Now, let's just put it in the create graph function. We will change this later, but this is just for example to know that everything is working properly. Let's Control S to save. If we go back to our localhost 8000, refresh the page, we see that the graph is generated, and it's the same graph as in the example provided by C3. We know c3.js is working. Now let's actually develop our own custom graphs. All graphs in C3 follow this general format, and there are a couple of extra manipulations that you can do, like axis, data formatting, manipulating what format the x-axis or y-axis is. Alright, so off the top of my head, the first thing that I want to do is I want to move the graph, because as you can see right now, it's all the way to the top. That's pretty annoying. From the top of my head, you can do something called binding. So what binding does is we can do a bind to a particular ID. In my case, it is chart. And why are we doing this? Well, chart refers to something at index.html. It refers to IDs. When you have an ID in the HTML, you can refer it with a hash symbol. And in this case, I'm just using chart to put the graph a little bit downward to look better. Let's refresh the graph. But it is binded to this chart ID. We can do something like BRs. BRs are return carriages, which means that it will be spaced down that's not, and I'm doing that as an example. And you can see that since chart is binded to the ID chart, it goes downward when I do BR tags. Alright, so now it's positioned a little bit downward. That's pretty convenient. I'll just leave that like that. Next thing we do, creating a line chart with that data. How do we do it? Now we know that the results.data is inside this variable called data. It is now known as data, at least within the context of this function. We want to take that data and get exactly what we need. What type of chart do I want? Let's take a look at a CSV file. It would be cool to have an x-axis being years and the y-axis being the amount silver minted per year, and a line graph being whatever it is. This is the type of graph that we want from our CSV file. I visualized it. I know what I want. I want the first section and I want the third section. All right, how do we do this? How do arrays work in JavaScript? Well, to do this, first of all, let's take a look at how data is formatted. Let's create two values. I want years equals arrays. How c3.js works is that all the data should be in arrays. So first, I know that I want my x-axis to be years, so I create something called years. Now, I want to create a new function called silver minted. Not a function, I made a variable called silver minted, and it's another array. These are empty at the moment. We want to fill these up. The first thing that I want to do is I want to use a for loop to traverse all the contents of data by row. Now, how we do that is do something like this. And since console.log is our friend for debugging purposes, I want to check every position of data when it is at point I. These are how for loops work. I'm going to assume that you know some programming concepts, so I will not explain this over if you already know what for loops are. Let's delete this top console.log so that they don't get confusing. And then let's just refresh the page. Now we see every single row. Basically what we did here is we started from 0. Arrays start from 0, by the way, if you are not familiar with arrays. And we went down the list. We went this way, and we just printed everything on that current line. We printed the entire line. That's how it works. So now, as we go all the way down until we reach the length, until we reach 1800, we're seeing the entire line. And that's why when I refresh the page, I can see every single line individually instead of this gigantic array within an array. That's how the for loop works. And now what we can do is we can take a particular portion of that line. For instance, you can see in this array itself, everything is separated by a comma. Arrays elements are separated by commas, and we want the first portion because we want years to begin with. But we also do not want the first category, so we want to start at 1 because I said that arrays start at 0. We want to start at 1. That's the first thing that we know. And we want to get the first category, so that is at element 0. What changes do we have to make? Let's do this. Every row, we want to get element 0. We do not want the category names, so instead of starting at 0, which is the first element, we want to start at 1. Let's save this. And since we're console.logging, we will see the data that we'll have. Let's refresh the page. And we see that every year is console.log. This is how you should be developing. See what data you are, console.log everything, and you'll be on your way to independently develop your own web graphs. Now that we have a year, we want to do something with the year. Basically, all the years should be in this new array that we've created, this empty array. So what we do is JavaScript has something called push. And what push does is that it keeps on pushing each of the contents into here. As for silver minted, what we want to do here is, I know that it is the third section, so I will push the second element because it's always one number before. Because silver minted is this section, which is the third element, it is at element ID 2. Now, of course, what we want to do is verify that these two arrays are what we want them to be. And you always use console.log to double check things. We save this file, refresh the page, and we see that we have a gigantic array with all the years, and then we have a second array with all the number of silver minted. We have these arrays as we want them. What's next? Well, I noticed that there is a category number. So the thing about this is I want to name the category because it does start printing the integer numbers, but there is this spot, which is the name of the category. Because when we look at the chart itself, we see that it is called data 1. We see that the category is data 1. And I want to name it differently because silver minted needs a category name. Now, we need to push something at the beginning of the array. So what we do is, instead of making an empty array to begin with, what we want to do is, before we make that array, we want to just put the value of the category. Alright, that looks good. And as you can see for the x-axis, you do not need a category name. So you just put the category values inside the array. Alright, so now what I like to do, I like to copy and paste this. And all I do is change whatever I don't need. For instance, I don't want this data anymore, which is on the y-axis. And for my y-axis, I want it to be silver minted. Now, for here, for the categories, I don't want them to be cats. So I change it to years. And then all I do is delete the old stuff. You always build on top of examples. That's the best way to learn. And then, as you want to build something more geared to your own requirements, you change things. Let's refresh the page. And we can see a nice, beautiful graph from 1720 to 1800. Now, the annoying thing about this is that the years are all weird. This doesn't look pretty at all. Look at this. 1720 doesn't even fully appear, but the graph itself looks okay. I mean, I can see the category names, and as I go left to right, it does show the value number. This is not good enough. We want to do something more. We want to make sure that these ticks look perfect. So we go back to this graph, and we know that we have a problem with the tick marks. What you can do is look at examples and go to tick fitting. Set tick's position to X of data. This seems promising, but not that useful. We keep on looking at the examples, and Google's always your friend, so you can check what Google has to offer. Now this is really useful. Culling. Max colon 4. Number of text will be adjusted to less than this value. This is exactly what we want, because as you can see here, in the data set itself, it goes from 0 to 22, but it only shows 4 of the x-axis tick marks numbers, because we have this culling over here. So what we want to do is, it is also in the axis category, so all we do is copy and paste. Copy this section, find the x-axis, it's years, put a comma. Alright, that looks better. I got confused and deleted tick by accident. Let's delete this comment and refresh the page. Now it looks good, but something's still wrong. Why do I have this not on one line? Well, there's a neat thing on C3 that I was about to say that we should have done. For the tick marks, there's something called multi-line. And we can set this to false so that the strings don't go multi-line because it just looks ugly. If we refresh this, we can see now they are separated and stay on a single line. But those tick marks, that's not too many. I want a little bit more tick marks. Like 12 should be good. Maybe 15. And now it looks pretty good. This is what I like. We can see it, the x-axis pretty cleanly. Things look pretty nice to me. Now we can play around with this and create different graphs with c3.js, but I think I've given you the basic foundation to be able to learn how to create web graphs from c3.js and PapaParse. We know how to parse the data from the CSV file, and we know that we can always get any example and Google search any of the problems that we may need. All of these examples, like bar chart, are in a similar format. They take data. In this case, for bar chart, you have to put the type, but the manipulation in all the tools that you are provided are within this examples page. One thing that I want to show that might be useful is the legend position and zooming. Now for zooming, this is very useful when you have a lot of data. How does zooming work? All you do is add zoom : enabled. This is a very nice feature that I personally like. And all we do is make sure you add the comma at the end of any section of C3. And we leave it the zoom part. We save. We refresh the page. And now zoom is enabled. How does it work? Well, you can drag. You can use the scroll button to go into any specific point. And if you drag left and right, you can go left and right. That's all there is to zooming. This is pretty useful when you want to show someone a particular point in your very complex and long graph, especially if you have as many tick marks as I do. Last but not least, I was going to explain the legend. How do you manipulate the legend tooltip? Well, it's provided over here. Legend tooltip, chart options, you can change height, width. There's so many potential possibilities with c3.js. Just always look at examples. Legend position may be useful. I know a bunch of people don't like the legend being below the graph, and you may prefer it to the right of the graph, which is something that you typically see. Copy this legend and paste it underneath zoom. Save. Take a look at the graph. And now the legend is at the right side. This looks like a pretty nice graph. You can create any combination of graphs that you want. Hopefully you learned a thing or two about making website graphs from c3.js and PapaParse. If you have any questions, leave a comment in the video and be sure to check out the source code. Thanks for watching.